Hey, Santosh.
Hey, can you hear me?
Yeah, I can.
Awesome.
Hey, Raj, good to see you, man.
Same here. Same here. How are things with you?
Good.
Good. Hanging in there.
Good morning.
Morning, Jeev.
Good morning.
It was so quiet for a second. I thought my speakers weren't working.
Yeah, sometimes it's like very eerily silent.
They've just gotten really good at the noise cancellation, I guess. The expense of all other usability and experience features.
I guess most people actually just mute, I think. Morning, Niels.
Hi.
Thank you for sharing everybody's faces. That's always good to see. It's like the time of the week or couple weeks that I see a bunch of folks. Oh, so this provoked Jeev to share his face. That's awesome.
I've been getting a lot of shit for it, even at work, so just gotta get more on the camera.
I think we didn't send like the invite again on the Slack yesterday, so I think some people missed it, but that's okay. I just posted the link. I didn't even know that people actually knew of that one. So. And this is an interesting problem, like getting your Google and your Slack membership to be in sync and resharing the invites as people join in. Doesn't really work well. Oh, hey, Jake. Cool. I think we should get started. George, you want to kick it off?
Yeah, I'm logging in. Hang on a second. Okay, now we're all set. Morning or afternoon, everybody, depending on where you are. I think the main folks up today are Prafulla talking about our new Flyte CLI that they have been working on. And I think that's it. I think that's our main agenda item for the day.
No, Jeev is gonna go over the getting started guide and the onboarding stuff.
Oh,
Yeah.
cool.
All right, sorry that didn't make it into the agenda.
I've also
Thanks, Jeev.
prepared some slides about the Helm support. So if you still have time, I can show that. Otherwise, I'll do it next time. That's fine too.
No, we have time. Helm support is actually, we've been talking about it. We just want to move away from customers. The more we think about it, it's like getting painful. So we love that. Should we do it in order? Is it okay, Sören? Like, would you be okay to go like the third in line?
Yeah, sure.
Cool then. Jeev, why don't you kick it off?
I thought we were going in order.
You are
Okay,
the prime
alright.
celebrity here, so.
Oh lordy. Okay, let me share my screen. Of course, everything is messing up.
Oh, before
Okay,
we start, sorry, Jeev, who's taking notes? Just to make sure we have one person who's taking notes.
I will.
Oh, perfect. Thank you.
Oh, sorry, who was?
I'll do it.
Are you okay? Thank you.
Okay, let's do this. The Flyte team has been really amazing in putting together this doc for essentially helping new users kind of onboard onto Flyte. As you all may, whoever's kind of operated on Flyte before, you may know that there's a non-trivial overhead to bringing a cluster up and starting to play around. And this is typically not something that new users want, and they just want to like basically have a couple of commands to fire things up and start playing around with the API, registering, running workflows, and seeing their results, and so on and so forth. Just kind of getting used to that experience that Flyte provides. And so, I'm going to start with. There's actually two docs, but I want to start with this one because I want to. This is the kind of like the first thing that we worked on last week, and then we'll talk about some of the improvements that are probably that are coming inevitably next week or later this week. And so I just kind of want to. This might not be super interesting to everyone, but like who are new users might be interested in this. I'm just going to kind of walk through all the steps in this and kind of share the experience of getting the first workflows going on Flyte. So let's get started. So I'm just gonna copy all these commands. Let's just create a virtual environment first, and this is a live demo, so bear with me if there are errors, which there might be. So create a virtual environment for myself. Install flytectl. Perhaps I should have done this before, note to self for the next one. And then simultaneously, I think we can basically like go through and start the cluster and stuff simultaneously. This is an block. So if you don't have the FlyteSnacks repo on your local laptop, you can go ahead and git clone it and cd into it. I've already done that, and so I'm going to go straight to this make start command and run that. As you can see, my flytectl is getting installed in my local environment, but this make start does not depend on flytectl being installed in your local environment. All this does is it creates a Docker container that will run a sandbox Kubernetes cluster and deploy Flyte to it. And so we'll kind of walk through all the steps. And so here, it says preparing dependencies, and currently the dependencies are just Docker and kubectl and core utils in Mac, as it turns out, that I learned yesterday. And so it starts K3s within this Docker in Docker environment. And it uses Docker and Docker here because this allows us to basically build the image nicely on the container itself, as opposed to building and pushing to a registry or building and kind of loading it into the image. So after it creates the cluster, it came up pretty quickly. And this time might vary for people. On my laptop, it's actually pretty fast, but I can imagine that this can be slower if you're on a slower laptop, or if you have fewer resources kind of allocated to the Docker VM on your Mac. And so now it deploys Flyte, and it goes through the process of essentially loading the sandbox environment in the Flyte repo onto your sandbox cluster, Kubernetes cluster. And at this point, it will, it's essentially just kind of waiting for the Flyte deployment to come up. So it's waiting for like Flyte admin, data catalog, Flyte propeller, and so on and so forth. So it's kind of just monitoring and waiting. And once that is gone, once that is done, the next step will basically be to kind of register, auto-register your first few examples to get started with, right? So that is essentially, whatever image that has been pushed in Flyte Snacks as like the latest image, and so that'll contain like some simple examples to get you started. And when this is done, so basically now Flyte admin is up and running, and so we're pulling down Flyte Cookbook, which is basically based off of this repository, and we're registering that image and all the workflows within that image with the cluster that just came up. And so that's part of the make start experience here. Again, this might be a little slower or faster for people depending on your network.
Hey, can I ask a few questions here?
Yeah, sure, of course.
So I'm just wondering, like, I mean, there are a lot of things kind of thrown into this entire demo at this point of time. I think cluster management, for example, bringing up a K cluster is not something that a user would do. It's more like an admin thing. So I was just wondering, like, if you can separate, like, okay, these are the steps that the admin does, and probably most likely in an organization, you should just get it out of the box. Here is what steps you need to do, maybe 1 or 2, and then you can get started or start writing your jobs. That kind of separation might have been more helpful. Just a thought, but I'm a product manager, so I found it very hard to kind of figure out where is the admin part separating out and where is like, how can I build a pipeline? So if you can kind of, not now, but sometime at some point of time when you guys can actually think about stuff.
I think it's an excellent observation. I think the goal with this first tutorial is for very, like this your first interaction with Flyte, right? You don't have an organization that's running Flyte. You don't have admin, sitting on the side to set up a Flyte cluster for you. It's just you on your own. You found Flyte on, Google, and you want to give it a shot. And we wanted that experience to be as simple and straightforward as possible. So we packed as much Flyte as we can in this one little box to give you the full experience. This is by no means the way you will end up deploying Flyte in your organization.
Makes sense. All right, sounds good.
Yeah, Santosh, this just to highlight, your question was getting admin to set up, right? This is actually running it locally. There is no admin at all.
I get that point, but the point is still that, in a user's mind, if he knows that, okay, in the steady state, I don't have to do all these things, launching a Kubernetes cluster, for example, or all the other work, it's just a one-time thing. It's still very relaxing for me that this is a one-time thing. For pipeline work, I start with this step, and there are only 3 or 4 or whatever they are, simpler ones. So just like whenever you're even writing it down or demoing, it's like, okay, this is one-time thing, 1, 2, 3, 4, 5, boom, you're done. You don't have to repeat it ever. The second steps where you will do regular work for your each pipeline development, this starts with here. Mentally, that's a model that I have in mind when pipeline development is like, a thing. So might be helpful for people to grok it better.
Absolutely fair.
That's a fair point. I think it might make sense to kind of just update the docs to say, kind of like the dependencies or the components of Flyte and like how one would bring them up and like what the responsibility is for all the different parties. Just a little bit of context here. At Freenome, we were actually running something similar where we had a Flyte sandbox repo that we would essentially use to kind of bring up these ephemeral clusters that people can use to work on. And we found that like earlier on when we were onboarding our engineers onto Flyte, we found that to be like pretty useful in basically allowing them to like move much faster in kind of just firing up their own playground either locally or some cluster and just kind of playing around with things and getting familiar with like the API and stuff like that. And we didn't, that did not require some admin to set up a cluster. And in a way, like that almost allowed them to move faster and kind of like learn the SDK and get familiar with it faster. So I think this is a good way to kind of just get started. But we should, I definitely do agree with others that we should probably call out that like, some things are not, some things are the admin's responsibility, but they're just kind of simplified here in this demo experience. Thank you for that suggestion. Cool. So now, as you can see, like, we've gone through and kind of registered all the workflows in our latest Flyte cookbook example. And the deployment is ready now, and you can basically, just go to this site here, and you can you see, your examples. And we should probably kind of describe this as well, but all the examples are essentially in this Flyte Snacks development project. And I'm gonna, for the purpose of this demo, like look at this one example, which is the Hello World experience, Hello World pipeline, and we'll just kind of go ahead and just launch it off, and you see, kind of follow the UI and see what's going on. I also like to see what's going on in Kubernetes, so that's a good way to kind of know what's going on there. And so, like, I will just Docker exec into my container. And this is not a part of the experience, but this is just something that I want to show in terms of like what pods are coming up and like how they're going through their life cycle and stuff like that. So we'll just watch. So you can see that there's this pod which has just come up in the Flyte Snack development namespace, and it's running and completed now. So if I go back here, you can see that this pod is now complete, and you can look at the logs and look at the inputs and the outputs. There's no inputs, obviously. And the output basically says Hello World, right? So let's go to the Hello World workflow, and that's this one over here. And you can see that essentially it takes, this workflow takes no inputs. It calls this say hello task, and then returns whatever the say hello task returns, basically. And so you can imagine, like, when you run this workflow, obviously it will have printed Hello World as the output. So let's make some, as part of this, like, I would like to following along here, we went through all of these processes, and I'm gonna try and make some changes to this workflow and do a fast register and see if I can, those changes that I made to my pipeline are now reflected in the new version of the workflow that'll run on Flyte. So I'll just, you can kind of follow along and just kind of make the changes that are described here, but I will just, I know what they are because I've kind of practiced this a few times. So essentially what I'm doing here is I'm passing a name argument into this hello task, the say hello task. And then when I'm returning, I'm basically printing Hello World and then that name, right? And so the input, we have to pass the input into the work. So when we're launching the workflow, we're passing the input into the workflow, and we're going to pass then that input from the workflow input into the task. And then you would expect, this return result to basically be Hello World and whatever name you passed in. So you can also test whatever changes that you make to your workflow locally. And so, like, I can essentially modify this thing, to be able to run locally. So like I can basically go here and run this command, this Python cookbook core basic Hello World command, and that should make sure that I do see a Hello World atom printed. So this is a way to, so there you go. And so this is a way to just kind of make sure that whatever changes that you make on your pipeline is just locally tested and it's ready to go before you ship this new workflow off into some remote environment and run it in a distributed cluster. So now I've got it running. I can basically just run make fast register. And what make fast register does is it essentially like serializes all the code in this repository and ships it off as like a tarball to the cloud, and then that will then get pulled down by the image, pulled down by Flyte and run in the cluster, basically. So this is all really nice sort of convenience tools. I'm pretty sure it's like fairly it's doing a lot of magic for you in the background, but that's hopefully like all that magic is hidden from you. You can just kind of do your work and iterate on it quickly. So I'll go ahead and make fast register, and you can see like this should go pretty quickly. So I made a small change, and everything is registered and is ready to go. And I can go back now into my, sorry, I'm just moving around my my images here, and go back to my cluster. And you can see that when I launch now, there's a new input that I can enter, which is the input that I was expecting. And I'll just type in a name here, Barney, and launch it. And so then you can follow along. This time I'll kind of just stay in this UI and you can see the task coming up and whatnot. Yeah, it's going. It's running.
New performance, Jeev.
I'm sorry?
You need my new performance turbo boost mode. That'll give it a kick.
Maybe my laptop's just, I can feel my fans are spinning up right now. So, so you can everything is like slowing down. There you go. So if you look here, you can see that like it came up, container creating, running, and it's not completed. And that is also reflected here. And so you look at the task or the workflow output. So this is still getting ready. There we go. So it's complete, and I can look at the outputs, and it says, oh, I guess I didn't. Did I not pass out the outputs here? That's odd. We should look into that. But
no, you can look at it now. It was succeeding.
Oh, I see. Okay, got it. So outputs, there you go. So hello world Barney as opposed to just the hello world that we saw before. And the only change that we did was just in the Python code. We did a fast register. And that doesn't require like a rebuilding of the image, right? It just registers all the code that you currently have and uses the existing image. And kind of like a caveat there is that like if you change the dependencies that you have, then you probably will need to rebuild your image. But most of the time, like people are just reusing like whatever image that they're using, with SciPy and all that stuff, and then they're just launching things off and they're just modifying their code. And so this is a good way to get things registered and iterating quickly on it. So that's kind of where we are with this particular tutorial. So So essentially what we've done is we brought an ephemeral cluster up. We ran a workflow on it. We made some changes to the workflow, and then we reran it again first locally to make sure that all of our changes were correct. And then we did a make fast register, and we ran that workflow again on the cluster, and everything worked out as we expected. So that's this hello world tutorial experience, and thankfully everything worked for the most part. The improvement that we're making is that we want to try and simplify this even more for people that are just kind of want to work off their own repos and whatnot. And so what we started to do was essentially put together a Docker image that will, when you run it, it will run a sandbox Flyte cluster for you. So this is kind of to Santosh's point. This is what the admin, if you were running on a cluster, like all the stuff that happens in this Docker container is what an admin will run. But what this will allow you to do is like, you can just spin this up either on some remote cluster or on your own local laptop. And then you will have, a fully fleshed out like Flyte deployment ready to go. And then you can start iterating on your pipelines as you would normally. So this is, this doesn't require make start and stuff like that. And what we're planning to do is we're going to take this image now, and we're going to replace some of the core internals off that make start command with this image and try to make everything a little bit more seamless. This is still kind of work in progress. One thing, this brings up a cluster, but one thing this doesn't do is kind of register example workflows. And so, that is work in progress, but for now, I can just show you what that looks like. So I can fire up this command. Let me just go and tear down my old cluster. Make sure that doesn't exist anymore. So it's tearing down my sandbox. Okay. And so I have no more containers running. Great. And now I can create this new cluster. So it does find the image, pulls it down. It basically is currently a 139 megabyte image. And I think we can probably make it a little better, but it's fairly small and it should be pretty quick to download on most laptops. So again, that's the same stuff. It starts the Kubernetes cluster, it deploys Flyte. And then it waits for Flyte to become ready, and that goes to the process of checking that all the deployments are up and running. And we actually have two different versions of this image. One is what I'm currently using right now, and then there's another one that is based on Docker in Docker. And what that allows you to do is the same thing that we did with our example, where you can build your images directly on your cluster if you want. And so there's no overhead of like having to push the image to a registry and then pull it back down to your cluster. You can just deploy, build and register the images directly on your cluster. So here you go. Everything is coming up, it looks like, and we're just waiting for a couple more things to come up. Sorry.
Sorry, just a quick question on the Docker building. How's the comparison of like the time aside from the network stuff? Just like, do the builds run pretty much as fast?
Yeah, so the builds run locally. And the thing is, like, you don't have to push, right? So typically, like, if you build, say, like a 3 gig image, if you're having to sit there and wait for 3 gigs to push and then for 3 gigs to pull down back into your container, that's going to take a while. Whereas if you just kind of do it locally, then you don't have that overhead having to push the registry. And as it turns out, like, building, people's computers are fast enough to build, but their internet is always like kind of a little bit shitty to like push 3 gig images up. And so it's nice to have things working locally. So now we have does that answer your question, Lior?
Yeah, it sounds like the building itself is like not that intense, and it runs really, the actual building runs really fast.
Yeah, so the building is dependent on like how it depends on your image, right? So like you might have like 100 or 1,000 dependencies that might take a while, but like if you just want to, if you have like a sandbox type of environment that you want to play around on, like that should be fairly quick to set up. Yeah, just depends on how many dependencies you have. Cool. So now there's this image. So there's this message that says the flight is ready and it's available, and I can just like click on this, and now I have a brand new cluster ready to go. And so now you can do the same stuff that you do, build your images and register with the cluster and so on and so forth. Unfortunately, there are no examples yet in this. It's a brand new cluster, and we're working on being able to register our cookbook examples into this cluster so people can have a much nicer first run experience. And so please stay tuned for that. That's all I have. I'm happy to take any questions.
Hey, one quick question. So what is the development or recommended development cycle for developers looks like now? I mean, you had earlier, I think you were showing the development, staging, and production, and then you have something local sandbox. So, I mean, what is the recommended way to kind of go through all these? When should one transition from one to the other?
I will defer to the Flyte team on that. I think, and I'm happy to talk about like how we do things at Freenome, but I'll let the Flyte team answer that question.
Okay.
Let's talk about how you do it at Freenome first. Then I will try to answer it.
Yeah. So in Freenome, essentially, like we don't have like these different. So we there's one cluster that has multiple these things called multiple domains, and so like development, staging, and production. In Freenome, we only have a single domain, but we split a cluster. We have different clusters entirely for development and production. So it depends on how you want to end up doing it. So you can have like one Flyte cluster and have both development and staging and production running on it, or you can have multiple Flyte clusters, which is what we do at Freenome, and then we have just one, which is like either a main or a default domain for that environment. So when you're developing, you're on the dev cluster, and then when you're ready, you just update all of your your customized templates, and then when you deploy it into production, we have it'll like automatically register all of the workflows and stuff, and then all your production workflows will be available on the production cluster for you to run.
Right.
We do have a local environment, and the beauty of that is that like if you just want to understand the API, like sometimes you don't know if like this thing is going to work, this thing that you're trying to do with the Flyte API. And you don't have to like, sit and try to keep pushing your image to a registry to understand that, right? The beauty of that, if you had something local, you can just like write a quick like foobar example, and what are you trying to accomplish, and then just run it on your local. And so at Freenome we have, and as well as Flyte Snacks here, there's a lot of like foobar examples that you can play around with and see like what works and what doesn't work, and really try and get a sense of what the API can do for you. And so that's what we use local for. We don't actually run any real workflows on our local environments.
Got it.
Yeah. So to answer the follow-up question to that, or maybe the prior question, the way we started building Flyte is we realized that it's impossible to run everything locally. It's just, especially with the hardware constraints, security constraints, and there are a lot of demos out there for a lot of products that say things will run locally. They're lying, like it just doesn't run. So, and again, I'll go on record saying that. But we do realize that running locally is very, very, very powerful. And that's why all the demos talk about it, right? It's just because it's so powerful, it's so quick to get started with. And that's one of the reasons why we put so much effort into this getting started. Actually, just kudos to both Jeev and Helm. They've been working on this. The thing that I actually discussed with them once was like, I want like to get started with less than 2 minutes, and literally it's less than 2 minutes today, which is just phenomenal. So the experience that we wanted to provide is like most of the companies eventually will have a hosted Flyte cluster if they're users of Flyte. And once you have a hosted Flyte cluster, you will use the hosted Flyte cluster, right? And that's why we have domains in there. Now you could divide the entire, like the clusters themselves to be separate, segregated, which is what Freenome does, while Spotify, Lyft, and a few others don't do that because it's not necessary. Internally, you could divide that. The benefit of either one is that isolated domains in one of them, and which is actually pretty good. You can always test and deploy things very, very isolatedly. While in the Lyft case, right, you will deploy only the data plane multiple times, but the control plane remains steady, and it decides when to send things to other, and the users get a consistent interface. So that's how we develop domains. And so the ideal iteration structure is knowing that there is a hosted cluster is you write code in Python or in Java SDK, you run it locally. Now that run it locally comes with a caveat, because that's why we spend time that Python itself runs locally. But like if you're using, let's say, distributed PyTorch or something, you can't run it locally. So it's okay. You run whatever you can locally, and it'll try to run it on one machine. And the idea is to get a sanity test, write unit tests for each of the tasks.
Yeah.
If you want to, even further improve it, which I highly recommend. And so everything is unit testable. And then the last step is you use Flyte type system. So if you saw, like, he wrote name string. Now, if you try to pass an integer to it, Flyte will complain. Flyte will not let you pass an integer to when you expect a string. This is another additional level of security where it tries to prevent or protect users from having problems at a later point in time, because pipelines invariably tend to be very expensive. And so if you can find all of these problems right at the point of writing the code, it's much easier to debug and prevent mistakes that can invariably happen when in the user's workflow. So once you are happy with all of this, you should push your code to Flyte development environment.
Okay.
Test it on remote, because no amount of local testing is ever going to do scale testing. So then you can test it on remote, and development can be as scaled as you want or as low, and you can have quotas and so on. That's what all Flyte comes with. But you may want to iterate now. You might find a bug in remote, and that's why we are, again, it's experimental. I want to remind that, but make fast register, or the fast register stuff that Jeev showed, is essentially to take that point. After your remote, you find a bug, take that bug and fix it, and reiterate and rerun. We wanted that iteration cycle to be less than 5 seconds. Literally, that's the goal that we went with. And so it is less than 5 seconds today. It comes with caveats. If you add a dependency, it's not less than 5 seconds. But you're not, right? You're iterating on bugs.
Exactly.
Once you're happy with the bug, you should never use fast register in the ideal world to move it to staging or to pre-prod or production. And once it's in production, every fix should be subsequently done using a full loop, right? Like this. So you're now testing locally, you're testing remote, and then you're going to production, and you get this entire life cycle of pipelines naturally through the system. So that was the idea, and the idea is also development has different access rights.
Yeah.
Each domain can have different access rights, different roles, and so on. Production has different access rights, so you can't go and corrupt data from production when you're running in development. You can, though. It's up to you now. It's like the administrator and the users of how they set up the Flyte environment, but that was the goal.
Got it. So just to make sure that I understand, so the way I look at it is that you do whatever you're testing, you will run only your unit test when you are doing things locally. Once it goes into the development, effectively all the functional tests, more tests than what you have written probably for your module, all of them will be running, and now that's passes. And probably that happens at regular cadence every few hours or something like that. And from there you go to staging.
So you run your own tests, right? When you go to development, yeah. I mean, like, you run your own integration tests. Like, let's say you're using SageMaker or BigQuery. You can now run a BigQuery query and get results from BigQuery and pass them into your algorithm. That's the test. It's not like the user doesn't care about what the system's doing. Like, system tests are only administrator dependent, right? The user shouldn't care about it. The user should expect that Flyte is fully reliable as a hosted endpoint, like an AWS service, right? That's or a GCP service, right? It's just not. That was the intention.
Got it. And one quick question: you said that it's basically determined by the control plane. So, in order to move from dev to staging to production, do I have to make any changes in my code, or is it like just that I specify the domain and it will run on those domains or something? Okay.
Yeah, no changes in code. Whatever changes are either by convention that you guys want to do, or by within the company, or by recommendation. So, for example, at Lyft, we have different roles, like IAM roles, AWS roles associated with different domains, and and we have different life cycle on the Docker containers themselves. So things that once get to push to production don't get pruned, but while the Docker containers in development get pruned like every 7 days. And the data also, right? We have policies on data. Data generated in development gets pruned very quickly. Data generated in production doesn't get pruned, and with lifecycle policies. So this can be enforced just purely based on it's convention based, right? We just provide the names and the title. These names are arbitrary. You can come up with your own name called Santosh's domain, right? It should be fine.
Yeah. Last question: do you have like identical data feeding into all these environments from local to production, or can you actually set to read from production data directly? Because I don't think you modify data internally.
No, so yeah, you can set whatever. It's role-based access control. So you might want to create sample sets which only are available in development. If your organization or the data organization is mature enough to have those kind of things, you can enforce. But yeah, today we cannot really control for what you access.
What is possible? That's what I'm talking about here. Okay, sounds good. Thanks a lot.
Yeah, Santosh. So at Freenome, we do have, we can read from production buckets in research if we want. So those are all handled by the administrator, and hopefully the user doesn't have to worry about it.
Got it. Makes sense.
No more questions. We can move on. I think we're like 35 minutes in.
Very cool, Jeev. Thank you.
Hey, Jeev, how big is your computer? Just curious.
It is not as big as Haytham's as I've determined. But
I mean, it's like an i9 with 16 gig or something like that.
i9 with 16 gig. Yeah. That's
okay. Just
2019, early 2019 spec. Yep.
Okay. Yeah. So not the biggest Mac you can buy, but close.
No, definitely not the biggest Mac you can buy.
Okay. All right. Thanks. Prafulla, do you want to take it away? Do you want to share the CLI?
Yeah, sure. Let me just share my screen.
Cool.
Okay, guys can see my screen. Okay, cool. So I'll go over some of the work that me, Ketan, and Yuvraj have been working on. So we have a Flyte console, which is the UI for interacting with Flyte, for running your workflows and checking their outputs and registering new workflows through the UI. So we have a corresponding Flyte kit, which is a Python-based CLI to actually interact with the same domain objects that Flyte provides. Now, what we are also working on is parallelly getting a Flyte CTL, which is synonymous to kubectl, and to have the same experience that you get through kubectl in Flyte CTL, and the same kind of semantics that you have in the UI and the Python kit, you will get it in the Flyte CTL. So you can create executions, you can create projects, you can register workflows. So currently we rely on all the workflows and the tasks which have been registered through FlyteKit, and we consume those as tar files or plain flat files, and we try to register those through Flyte CTL. So that's a nutshell. What exactly are we trying to do with Flyte CTL? Okay, just a second. So we have the documentation already published in the main Flyte page. I'll just go over that. So this is the link that we have for all the API CLI components. So we have, so we have I talked about, like, we have a Python kit. So I'll go over the Flyte CTL that we have been working on. And we also have a Flyte kit Java version. So this documentation goes over how exactly you have to install Flyte CTL locally. You just do a curl and install this. And there's certain minor configurations that you need to do to tell Flyte CTL where exactly your admin is running and what sort of settings do you need to communicate with that. I already have something running, so I'll just show you that. But and the way we have organized the documentation is also similar to how kubectl is. Like, you have verbs and nouns over here, how exactly you want to create some resources and get information about resources, or update certain resources, delete something, or register is synonymous to creating some resources over here, and config the nouns with so if you want to use a noun over here, you'll see like creating a project, or you're updating a project or something like that. So let's just give a small demo on how exactly these things work. So the documentation gives a run by of how exactly you want to go about running these commands. So so this is a simple Flyte CTL create for creating a project. It tells you like what all flags are available for that particular option. So for project, currently there's no other additional options other than the file. So I'll just go over. Yeah, so this is the example Flyte CTL create project option. So sorry, it has options. It's not there in the main page over there. So here you have creating a project requires the name of the project, the ID of the project, and the description. There's another way that you can create a project is just give the input of a flat YAML file with all the contents, and you should be able to just pass in to the file flag and it will register that. Once you have, so this is the first thing that you usually do. You create a project, and once you have the project, then you start registering all your tasks and workflows in there. So over there, once you have created the project, then you'll start registering stuff into that project. So this is similar to how you do in Flyte, Python, or Java. You specify where are your all your serialized files. So in this particular case, I say Flyte CTL register. My files are over here in this directory. I want to register it only in the development domain. The project is basically Flyte Snacks. Other options you have is basically you can just give a tarball, and it can be an HTTP endpoint as well, HTTP or HTTPS endpoint, or it could be just be a gunzip file of that tar. And so Flyte CTL would be able to read those and register with the running Flyte admin, whichever Flyte CTL is configured to point to. So just start with some examples over here, so that would be easier. So I'll just demo something. So I have a local version which has some minor changes. So I'll just go with that. That will be helpful. So this is the same command that for creating a project. I can just say that I want to create a new project. It says that the name is Flyte demo, ID is this, and description is this. and says project created successfully. There is other ways that you can do the same. So here, so there's a file option that you can give as well. So I have a YAML file that I've created for this. So project.yaml file, I'll just show you that as well. So here you can specify, similar to how you do kubectl deployment. So you can specify all the configuration in this file on how exactly you want to define your project, and it should be able to pass in this, you should be able to pass in this file and create the project. Okay, so I can just show you that option as well. So this gets you that project created. Now you can as well understand what are the projects that you have registered. So here you can say get projects, which will give you like what all projects that you have. So we had flytectl demo and flytectl demo file. This particular one was using a demo file. So that gets registered over here. And yeah, so you would be able to do the same. And along with the, inside the documentation, we have additional options that that you can do with the get. Is basically you can specify the name of the project itself. It will get filtered on that. We'll be adding more filters to get more details from the project and allow you to filter based on that. Or you can get the output of the project in a YAML or a JSON format. So that's also like pretty simple to use over here. So you can, so this dumps the entire YAML definitions of all the projects in here. Okay, so this is cool. Now I'll show the register file example that I was talking to you about. So I already have a serialized version of some of the workflows. I have put them locally. So this is a simple launch plan. This is directly from the cookbook, which just does a greeting based on the time the time parameter for that particular workflow. And what I'm going to do is I'm going to just register this. Okay, cool. So yeah, so this one says that I already have something with version 1 running. So you can additionally pass that, okay, I already have some versions already registered. Let me register a new version, version 10. And okay, so it has successfully registered all the other higher versions. If I do it again, it will fail the same way that it failed earlier because it already knows that there is a version existing. If you want to continue on errors, there is a flag option -c, which just tries to skip over any of the errors that it gets, so that it tries to register the rest of them. All of them are failing with the same issue. But if I just change it to version 11, now it should be able to say that I have registered this as a new version. Okay, and so that was for some of these. I also have, you can also do register using an HTTP endpoint. So I have an HTTP endpoint currently running as in Python. So just in this directory, and it will be doing the same thing. This one will complain again because it doesn't have these registered file already exists. So it doesn't matter, like we already have the same workflows, the latest versions of those running registered with Flyte. Now we'll try to see how these registered workflows actually look. So you can do get launch plans or get the actual workflow objects to see what exactly is the registered version with Flyte. So this will tell you, like, you can just do a get from the launch plan. Okay, these are the versions that I have registered. If you want more information about it, you can do a YAML version of it and dump the more detailed output of that. And yeah, so you can interact with the same way. Once you have registered, the next thing is basically you want to execute the launch plan. And so currently we are working on creating an execution. There's already one that exists in Flyte Kit, so I'll probably use that. So I just have this one which is for Flyte CLI. This is the Python version. I'll also show you what happens with the CTL version, also the same way. I think my IP has probably changed here. Try using. This is using a Flyte CTL. If something's off. It's pointing to the wrong endpoint. I'll remove the okay, this
Demo
one
gods.
thing. Yeah, it seems like it's using a TLS. I think I have turned it off. Probably some configuration that I'm missing right now. Yeah, it seems to be correct. Okay, I think it's running out of time, but basically once you have those executions created, you would be able to see it in a similar way in the Flyte console. So even in the UI, so here these were the existing ones that were running. These were the projects that you had, and the new one should show up, the one that we created. Okay. Yeah, I think my admin went down for some reason. That might have caused this issue. Okay, anyways, like we have the documentation. Please go through that and please provide feedbacks. And yeah, we would love more feedback on this. Thanks.
Are there any things that are still sort of largely missing between what you have now in the Flyte and the Python version?
Yeah, there are quite a lot. This is just like the basic version we are trying to get out, like where you can register, create executions, get some of these executions and terminate those executions. There are many other flavors and options that we want to add to these to be compatible with what we have with Flyte.
And so if somebody wanted to help and sort of jump in, is there like a list of issues, or how would I mean, it sounds like there's
Yeah.
there's a lot of surface area, right? That
Yeah, so we have the same, we have flytectl issues in GitHub, so people can pick up from there any new ones that are missing.
cool. Looks awesome.
Yeah, it's also nice
you.
to compartmentalize, so I think anybody can pick up and contribute pretty easily. If you are interested in learning Go, also this is one of the best ways to start learning Go, and it's fun to write like GTL stuff.
Yeah, this was my first time learning Go. So I'm mostly a Java developer most my entire career. So this was a good shift for me, and it was yeah, there were initial hiccups, but I'm getting used to it. Okay, thanks a lot. Yes.
Yeah, add one thing, like I think flytectl, the reason why we're building is, I don't know if everybody knows, is because you don't have virtual environment installed everywhere. What we want to do is have a portable binary that you can just do brew install or pip install, not curl install, right? And then the other thing is we have projects and so on, which doesn't have GitOps today. What Prafulla showed is essentially you can have project YAMLs that you can check into some master repository. If you want to use full GitOps for everything, including managing projects and so on, you should be able to do that now with this. And more so, right, going forward. So those were the intentions. Like for example, Flyte admin has ways of managing cluster resources, has ways of managing throttles, quotas. You can use GitOps for all of that.
I think we're close to out of time. I'm not sure, Sören, if do you want to try to sneak it in, or do you want to wait till next time? I'm sensitive to folks in India it's like late at night and their families are wondering what the hell they're doing still on this call, but
so perhaps
but also
better if I do it next time, so we don't have to rush too fast through it. I don't know. What do you think?
Kevin?
It's fine.
Up to everybody else, like I don't think I have also followed as much, though I've like talked to Sören a little bit, but what do others want? Like basically what Sören is helping with is building the Helm chart for Flyte, which is probably one of the most requested features by people. So
It's fine by me.
Okay. So
we'll go for it, and we'll take, the video will be up, and we'll,
okay.
If people have to peel off, then they can watch the video. I'll try to take notes.
Okay, great.
We'll just power on. So apologies to anybody if you need to go. We understand.
All right, and let's do it. Okay, let me just share my screen. Can you see my screen? Can you see my screen?
Yes.
Is it the right one, or is it the?
It's in presenter mode, I think.
It's in presenter mode, so it's
but I think it's fine. We can see. I can see it at least.
We can read it.
Let me switch. Maybe better now.
Yep.
Okay, great. So okay, let's talk a little bit about Helm, Flyte, and Helm. So we are currently in the process of integrating Flyte into our system, into our platform, and we use Helm, and so it makes sense for us to basically help with Helm support for Flyte, and there's also interest from other people as well. So what I want to do first is for people who don't know Helm, just to give you a brief overview, and then move on to basically what the Flyte part, what's been done and what's coming. What is Helm? So it's from the Helm website. It's a package manager for Kubernetes, basically a way to find and share and distribute packages of Kubernetes resources. And I don't have any numbers, but I think it's by far the most popular package manager for Kubernetes right now. So the main kind of the core concept of Helm are charts, which are basically packages, collections of files that describe a related set of Kubernetes resources. And there are three main ingredients of a chart. So one is the metadata, like name and version of the chart, version of the app, and also dependencies. And we'll see that in more detail in a moment. It's all and usually in a file called chart.yaml. And then there's templates, which are basically templated YAML templated Kubernetes resources. And third, there are configuration values, which can contain different deployment options, different variants, for instance, and then they can be applied to these templates to create releases and different variants of these resources. So here's an example of a chart.yaml, which is actually from the Flyte PR. So it just specifies the basic metadata like name and description and versions and so on. And it can also declare dependencies, which are basically other charts you want to include in your chart and use and basically deploy together with your chart and also configure. So here we have contour and the Spark operator, but of course, basically everything that is packaged as a chart you can use in your own. So you have some, which enables you to kind of decouple things and enable like software engineering best practices, basically. So templates are, as I said, basically templated YAML. So it's just YAML with text templates in it, and you can it's basically Kubernetes resources. So here we have a deployment, and what we can do is essentially say for certain fields which we want to vary for different releases, we can add this template mechanism and say, okay, this is something I want to change based on my values, and also it's not only the values, but you can also use like template functions to make it a little bit more flexible. But it's basically Kubernetes resources with some template values. And finally, we have the values which we can apply to the templates, and which allow us to or which allow chart users to override to customize the chart with some values. So usually you have the values YAML that comes with the chart is usually contains some default values. So here we have something for Flyte admin for the template we just saw, like which Docker image tag and resources and so on. But this is usually something you can override as a user. So one part of Helm is this template engine. So basically we have these three ingredients I talked about: metadata, templates, and values. And what we can do is to run Helm template with the Helm CLI, and out comes just raw Kubernetes resources, which we can apply, kubectl apply to a cluster. Just as something you get out of customize for instance. But Helm is also a release management tool, so we can also use the Helm CLI to actually apply these things to the cluster directly and to manage our releases, which brings a little more functionality. So if you use Helm that way, we can actually manage our releases and do all kinds of things to make sure everything is properly installed in the cluster. So there's a bunch of commands in the Helm CLI. For instance, you can install. We will see that in more detail, and also, of course, upgrade when you change things, which will also prune resources. So basically, Helm has metadata in these Kubernetes resources, which allows it to track which resources it tracks, and then it is able to also remove things you want to get rid of in an update. And also things like rollback if there's a failure, and of course uninstall releases and diffing with the help of a plugin. But of course you are not you don't have to use the release management. You can also use just the template engine basically, and use it and then use another tool for applying it to the cluster. So one interesting thing is that you can package your charts up into basically zip files and upload them to what's called a chart repository. And there's all kinds of repositories, and the Helm website has this artifact hub, which basically aggregates these different repositories, and you can just go there and look for Helm charts for different software, and then install it with Helm. So it's quite easy to basically get started with some existing charts and try them out. So this kind of looks nice, but Helm also has some issues, and actually we had some discussion in Slack. We're using it, but there's some problems, like for instance the text based templating. on YAML is kind of error prone, as you can imagine. And there's also the problem that Helm values are kind of static. So if you, it's especially an issue if you have, if you combine multiple charts, you can't use values themselves as variables. So that's a little bit restricting depending on your use case. And also, if you use the use Helm as a release management tool, it can be sometimes a little bit fragile. But things are getting better with every release. So with Helm 3, there was a huge improvement, because before in Helm 2 there was actually a server-side component which did all this talking to the Kubernetes cluster, and this was kind of problematic, and they completely removed it. And now it's more client-side, and that makes things also debugging and so on, makes it much simpler and easier to use, less error prone. And they also introduced three-way diff, so if there are some changes not from Helm on some live resources, it won't throw them away, and lots of other fixes. Also, it's, yeah, as I said, it's very popular, so it's always a plus because many people already use it. Yeah, I think the last point I've said it already. You can just use it as a template engine if you already have another tool to for release management. So, for instance, Tanka and CDKS, they all provide Helm support, so you can import Helm charts if you use that. So I think if you provide something as a Helm package, there's a good chance that many people, even if they use other tools, can actually use that Helm chart. So I think this could be quite helpful for Flyte as well. Okay, so let's move on to the Flyte Helm integration. So the first thing, or there's the PR from Ruslan Stanovic, who did quite amazing work to actually kick this off and create a first Helm chart. And he got the end-to-end tests working with his chart, and yeah, basically provided two variants with different values files for sandbox mode and EKS deployments. What's interesting is that he has that in his PR, most of or I think all of the dependencies are actually inline. So it's more, in that sense, it's kind of more similar to what we have now and with customized. So all the resources or the templates, even for things like the Spark operator and PyTorch operator and Contour and so on, they are integrated in the chart directly. So it doesn't use like the external available charts for external dependencies. And that's actually what I'm working on right now, is based on his amazing work. So all credit goes to him. Basically, he's done he's done all the work. Is to build on that and try to use chart dependencies where they are available. So I've started with Contour and the Spark operator. but I'm looking into adding more, or moving more dependencies into like the real chart dependency. And I've also done some updates for of the chart itself and the image versions and so on, because of course master, the customized version, has moved on and has changed, or is changing all the time. So my focus is on getting the sandbox running first, and then on PKE, because that's what that's where our platform runs. And yeah, hopefully I'll have a draft PR very soon ready, so people can actually have a look and try it out. But of course, Ruslan's PR can also just use this branch and should work, even though the Flyte version is a little bit older. Okay, so let's have a quick demo. So here's the chart in its current version. So maybe you can kind of have a little look before I actually try to install it. This is basically what we've seen in the slides, right? Can you see it? Is it large enough? Okay, cool. So we have the chart, we have the values file with default values, and then there's, for instance, this is the values, an extra values file for the sandbox, which is mostly empty, but has a few overrides where we say, okay, I want this local Postgres, for instance, with these settings and so on. And then, of course, here are the templates. So let's see. Just reset that. So the first thing I have to do, because I have these external dependencies, is to update them, or to fetch these dependencies. So I'm going to do a Helm dependency update, and hopefully this will download these two charts. Yeah, downloading now, and we should be able to see that in the IDE. Here they go. So what this dependency update does is just it just downloads these two charts from the repo, or from their repos, could be different ones, and makes them available locally, so I can actually use them when I want to deploy the chart. And yeah, IntelliJ is nice here with its Helm support, because I can just expand that, and I can have a look and see their chart. So we have the contour chart, which with all the settings, and of course also the templates and the default values. And so what's nice is these are the contour values, and I can, when I use that as a dependency in my chart, I can just override. Let's see. Yeah, I can override all the settings of any dependency, any subchart in here as well. So that's quite nice. Okay, so once I've prepared or downloaded the dependencies, I should be able to do a Helm template, which is this, which just basically renders the template. So when I give it, usually I give it the full name of the chart, but because I have this locally here in development mode, I just do it on I just give it the current directory. I give it a namespace, and I also give it a values file to be applied to the template. And once I do that, it will just render the template and give me this huge YAML. And of course, I can also write that into a file and use it similar to to the generated YAML with I get out of customize. But the other thing I can do is to actually use Helm as the release management tool. So let's give it a try. So here we do Helm install. We also give it the namespace and the values, and just fire it up. And what I can do here in the meantime, see what happens in my local cluster. And you can see it. The deployment was successful, so it just deployed Flyte, and in that case, it doesn't wait for all the resources to be ready, but it can also set a flag, something like wait for readiness. And now it should be. I can also do an Helm ls. So if I have multiple deployments, they will all be shown here, and I get the name, the revision when it was updated last time, what's the status, and so on, and the versions. And it should be complete now, I guess. So let's give it a try. Yeah, here we go. So we have this running, and should be able to actually execute something. So here I am in the Flyte snacks repo. So let me try to just register something. And here we go. Should have worked. Yeah, so now we are able to just run a workflow as usual. Yeah, so that's running. Okay, so now what if I want to change something? Let's go back to the IDE. So let's say I need another replica for Contour just because I'm here now. So I changed the values, or usually I would change the value here, but yeah, because I have it in development mode, I can just do it on the values, on the default values file as well. And let's see what happens when let's first look at a diff, right? It's always better to before you deploy something to look at some diff, what's actually changing. And there's a that's not baked into Helm actually, but there's a diff plugin which you can install and see what's changed. So let's call this Helm diff upgrade with our values. And then we can see that it should have just changed the replicas and the generated YAML. And if we actually want to apply that, we can do an upgrade, and yeah, it will just apply to the cluster directly. Yeah, I think that's basically it. Yeah. Are there any questions?
Not for me, but this is amazing stuff. Like I think there's only one team that uses Helm internally, and Helm makes it like very easy to discover and install is what I've realized. I'm sure there are many other problems with it, but at least the initial getting started is much easier, especially with cloud deployments. But I had a question. So I saw that you have dependencies on all of these other charts. So should we model like Flyte admin, Flyte propeller, data catalog as its own Helm charts, and then like make them as dependencies?
Yeah, that's actually a good question. I think I would for Flyte, for something like we have under control. I think it's definitely easier to start with like a monolith basically and put it all in one Helm chart, because it's easier to iterate. And also the question is, what would be the benefits of actually putting it into its own chart? I think most of the benefit actually is when someone else provides a Helm chart for some software and packages it up, so you can use it. So you don't have to maintain it essentially. But when you're maintaining it yourself, I think it's not really worth the effort, at least not to start with, to break it up into smaller charts. But that's my opinion. So maybe there could be a reason to do it at some point, if you want to kind of make it much more modular. If you have like, if you want to only install certain Flyte components, if you at some point, if you get to that point, then maybe it makes sense. But I think for now it's easier to actually have a single chart, but then use the external dependencies that put them into charts. My opinion again.
No, I think that's fair. I think the only reason why I think it might be good to not break it up into those many components, but like probably two components, is because the control plane and the data plane can be separated, and you can run in a multi-cluster mode, which can be beneficial at times. But when you're starting off, that's not. The good part of probably having, and I think you mentioned that in your slides, is that you can't use variables in values. So if I understand that correctly, then like let's say if I want to have one GCS bucket or S3 bucket across the two, like the control plane and the data plane, then I cannot really, then I'll have to re-specify it for each of the components. Is that right? For each of the
yes. Yeah, I mean, if you put it into, let's see, if you control the chart, I think you can model the templates in a way that it could come from the same value. Maybe then it's still possible. But yeah, the problem is more if you have like, if you have a dependency on a chart and it says, okay, I have like this for instance, this contour replica count, and you want to make this replica count, contrived example, of course, dependent on some value of your own chart, that's going to be hard. But I think this is another issue, actually. Not sure.
Yeah, I think that was probably what I was talking about. It would, because it would be a dependent chart, and it would
okay.
one value for both. But so another question in that, so you think, well, would this solve the config problem? I think the real problem with Flyte installation is the config. It's just so vast. With the flexibility comes like crazy amounts of configuration. There are very good sane defaults, and we usually do them in the code itself, but still there are some sane defaults for like a sandbox deployment and a AWS deployment or a GCP deployment, let's say. Can we hide that and config maps generated as well, or is that not a recommended technique?
Sorry, could you repeat the question?
Yeah, so is it recommended in Helm to actually use values to substitute sections of a config map? Because
yeah, I see. Yeah, it is. I don't know if it's really recommended, but I think for certain things it's basically the only way. So kind of to put like full YAML, for instance, into a value, and that's which then will be the content of the config map. That's what you mean, right?
No, I mean like the config map, can that be templatized itself?
Oh, okay. Yeah, no, that's not possible with Helm. So it's really, the templating happens at installation time. I mean, of course, you could have a config map. The config maps are also templated basically, but it all happens at installation time, right? So you,
yeah, but the difference is the config map is actually a string, even though it looks like a YAML. It's the data part.
Oh, yeah. Right? Oh, you mean the data part is, yeah. Okay. Now I get it. Yeah. Actually, I don't know. I think
my understanding is that you actually can. Yeah, you can put templates wherever you want.
Oh, really?
Yeah, I think so.
Text replacement. It's not really.
It is. Yeah.
YAML.
That's actually one of the issues that it's why it's kind of fragile sometimes, right? Because it's just text templating. It doesn't really know YAML or some structure, some even types or things like that, and that makes it. But that makes it also kind of flexible, so it should be possible. Yes, definitely.
Getting the indents right in your YAMLized config map, that will be the hard part, but it does work.
Yeah, exactly. Yeah. So this is can we see an example here?
The fun part of it.
So you see these functions here, right? So you type that to this and then because it's YAML, it's you have to make sure that it's has the right indentation.
Interesting. Yeah, because my biggest thing is to actually take config map somehow and make that easy. Now, I've been thinking of various different ways of doing that. It's like, I think besides config gen, which Envoy went with, right? Envoy actually, it's like one of the core fun things about Envoy was that it had config gen. Written in Python, you write the thing and it generates the config for Envoy because it's error prone to generate the config. Besides that, I just couldn't come up with it. I thought like maybe Helm could help us a little bit, but I don't know.
Yeah, perhaps there's a way. Maybe we should look into this more closely.
If you're Ketan, if you're just kind of like saying, if you're kind of writing your keys in the config map template and you're just like templatizing the values, I think that would be fine. And like you won't run into indentation issues with that. But like if you're if you're starting a string and then adding your template values, sorry, your YAML values in like as blocks, then you have to get the indentation really correct. Otherwise, it screws up. But yeah.
Yeah, but even if the values, like what if the user writes something wrong? Like it's just like it will not fail at the point in which it is built. It will fail at like installation time, and things will come up and crash.
Yes,
so this is YAML. Like,
yeah.
Anyways, maybe YAML lint or something might help, but then you have to generate the config map separately, lint it, and then plug it into as a. I don't know if that's possible. So
Yeah.
It's not necessarily a linting issue as well, right? It's like, is the value actually correct for that thing? Because then it would just kind of crash, like cause the pod to crash or whatever after the fact.
Yeah, but like crashing because of badly formatted YAML is worse than because of bad values. Probably we can improve over there, but like like badly formatted values, it's just like that will happen with this, right?
Yeah.
Okay, but. No, but I actually still like it more than customize. Customize is becoming a little nightmare almost to maintain for Flyte. It's too big.
I think it can reduce really some repetition that you can't avoid with customize. At least that's my impression. I'm not too familiar with customize. I basically only know the Flyte the Flyte deployment. But I think with templating, if you do it the right way, you can. If you have some like cross-cutting concerns, you want something you want to apply to basically all, let's say, all deployments or all pods. It makes it easier if you control the chart. So if you that's something that makes it a little bit difficult with to work with dependencies. Of course, you don't really control the templates in these dependencies, and if something you want to change is not templated there, yeah, you're out of luck. You have to fork the dependency basically, and that happens quite often actually. So, but if for your own charts where you are in control of the templates, I think it's much easier.
Yeah, Flyte has very few dependencies, to be honest, like on the Kubernetes part of the app system, but yeah, maybe it'll increase at some point. So this KF operators and SageMaker operator and Spark operator. So those dependencies are quite a few, to be honest. So yeah. Anyways, but this is awesome. Thank you.
Yeah. Hi, Ketan. Like,
Oh, yeah.
I just want to add one thing in the Helm thing. So like the config part, I understand the configuration is hard in Helm, but like we are using Helm as a packaging tool. So you package your Flyte tool as a, like by default values. Maybe you have some by default configuration in your config. But if I want to add more config and I'm running Flyte on production using the Helm, that means there is a two-way. One way is like I will fork the Helm chart, and then I will make changes in the Helm, right? One way. And the second way is like I will not fork the chart. I will just fork it, and then I will use the customize. So that means I want to write some configuration, like I want to change the config map. That means I will pull your Helm chart, and then I will do some cooking in the customization, where I will change the entire basically config using a config file. Maybe I have a config.yml, and I can use that file inside the customize so that I can replace the config map data value with the file value that I have. That means I don't need to change anything inside the Helm or anywhere. I just need to add the customize apart from Helm.
Combination of Helm and customize.
Yes. Actually, that's the right way as people are talking about. So use Helm as a packaging tool, but definitely each company make some changes according to them, like maybe some volume related changes and other changes. So it is good, like people will use customize on Helm rather than directly using Helm to build the chart and then deploy.
Sorry, I'm muted. I was just going to ask. So, are you modifying with customize the templated YAML files in the Helm chart directly? Is that what you're saying?
No, so basically in the Helm chart, we have some plugins for the customize. So you can use the Helm plugin to use the customize. So basically Helm will do gives the templating like a YML format, because it's like a templating engine that will convert your templating, and using the value file gives you the raw Kubernetes file, right? And when
Gotcha.
you have raw Kubernetes file, that means you can use customize to figure out the right resource and then patch the resource and then deploy the. That means I have the basic config using the Helm chart, but I'm using the config map so that I can pick the exact resource, that config map I have to change. And now I can use a config, like basically I have entire config in somewhere in my GitOps. Okay. And I can use that config file and customize to just replace the data. So that means I will not use config. Like if you see the other charts, like Nginx has a good thing. So Nginx ingress controller will give you Helm chart, you can deploy it. But if I have to make some custom changes like Nginx configuration, that means I have to manually change the configuration, or else what I can use it, I can use the Helm chart and then use config map. Basically customize so that I don't need to do manual changes. That's the right way. So we can set the example so that whenever someone start using the Helm chart, he know how to write customize, how to put the exact GCP or AWS file and then use it. Basically, that's the right recommended way to use Helm.
Yeah, I mean, I think this is something that, of course, combines the advantages of Helm and Customize, and I think there's people doing using Customize or something else to actually then patch the output of Helm or the customer the Kubernetes resources. On the other hand, of course, this also adds complexity. So we have now two tools, and it's I think it doesn't make it much easier. So in general, I think I try to improve the Helm templates in a way that they are flexible enough that that Helm is enough, essentially.
Fair. Cool, but thank you. This is awesome.
I have one last question, actually, more for Ketan. So if we move to Helm support, like what happens to Customize? Just curious.
Don't ask this question to me. I will let you guys answer.
Community will decide.
That's fair.
I actually, so Sören pinged me about something about Helm. I said, I have no understanding of Helm. Like, I don't understand Helm. I did not know Customize to the point, and then I rewrote the new Customize template that you see, and it's like, the documentation was in Chinese mostly, and I don't know Chinese. So it's like, if I wrote something in Customize, if it doesn't work, I couldn't read the docs. so yeah, I'm not the right person to answer this question at all. I think absolutely the worst person to answer this question. I can just say that we can't. So I can tell you, whoever's using it in production at some scale are not using Customize as much, except for probably Freenom. So what they do is essentially have their own weird ways of deployment. Everybody has their own weird way of deployment. For Flyte Propeller is where I think Customize is used more often, at least at Lyft and F5 and so on, and even at Spotify, I think. But other parts, Spotify also doesn't use it. But yeah, but I like, if the question was, will it break people if we change from Customize to Helm? It probably will, some people, and then we'll have to think about the right strategy, but it's not like a end game in that. We should do what the right thing is, but I don't know what the right thing is. So I don't want to make a call over there.
That's fair.
I think that's an elaborate I don't know, right, Ketan?
Sorry, what?
That's an elaborate way to say I don't know, right?
I have no idea. Yeah.
Okay.
I can see it probably. Yeah.
Yes, we will figure it out. Well, that was I think the lesson learned is we need to only schedule 2 things, because that was a lot. And a lot. I did my best to take notes, but when we got down to using customize as an input to the templating engine for Helm, my head sort of wrapped around an axle. So you might want to clean those up. Thanks, everybody. I think we've got 2 weeks till the next one. Please ping me or Kathan if you want to show something. But this is a lot of fun. Enjoyed it.
Yeah.
Thanks, everyone. Have a good day.
All right. Bye, everybody.